All right, guys, before we get started, are there questions on any of the homework assignments? Questions on any of the problems that you all want to look over? Huh? Okay. Questions on the homework? All right, guys. So far, our ways to solve quadratics, we've had a few, because we've had factoring, graphing, square root method were the first three main ones that we found, and all these work as long as it's set up correctly. Now, the first one that we learned that works for every single one is the completing the square. And realistically, completing the square is just a modified version of the square root method. Because completing the square, the first three steps of it, the main part of it, is to get it into a perfect square trinomial, at which point we can use the square root method to solve. But the nice thing with this completing the square method is it does not matter the quadratic that we have. It doesn't matter what we have to start with. It will solve it. It will find solutions every single time. So the nice thing about completing the square is that it will find the solutions for any quadratic. It doesn't matter if they're integers, rational, irrational, or complex solutions. It will find the solutions for those there. And I think for the most part we understood how that worked, the four main steps in solving that there. Yes? Kind of, sort of. All right. Now there is one other method that works for all quadratics, another way that we can find the solutions for a quadratic equation, these equations here. And that is the quadratic formula. Now the quadratic formula, what we're going to do here, and what I'm going to do here first, is actually get the quadratic formula. Now you don't have to write this down because realistically, you're never going to have to do this ever. This, what I'm going to do here, is really just a way for y'all to see how we get the quadratic formula, where it comes from, and how everything connects back to this here, our ax squared plus bx plus c, because this here is the a quadratic equation for any real number a, b, c. So any quadratic equation that is in this form, we can find the solutions to it by using completing the square. Okay? Because completing the square works for any quadratic equation. So what I'm going to do is I'm going to take this equation here and apply the completing the square method to it. I'm going to solve this thing. Even though we don't know what a, b, c are, we can still find its set equations. Because the first step in doing this is going to be dividing everything by a, because if a is equal to 1, is a equal to 1? If not, make it so. So we need to make that first term 1. Because a in this case could be 1, but it could also be anything. It is any number. And you don't have to write this down. You can if you want to. So if we divide everything by a, we'd have x squared plus b over a x plus c over a is equal to, well, 0. Because any 0 divided by a, no matter what a is, will be 0. Our second step was to get the constant terms by themselves. So we can subtract this c over a from both sides. And leave 2 spaces. Now that gets us through steps 1 and 2 of the completing the square method. Our third step is to find the value of c that would make that a perfect square trinomial, which is our b over 2 squared. Now this, again, some of our letters are repeating, and that's fine, because again, the meaning behind how we plug this stuff in isn't as crucial as what we're getting to. Our b term is the number in front of x, which is actually just b over a, over 2. And if we do simplify b over a over 2, we get b over 2a. And b over 2a squared, if we multiply it by itself, b squared is going to become, well, b squared. Our 2a squared, 2a times 2a is going to become 4a squared. So what that tells us is that we're going to plug b squared over 4a squared, b squared over 4a squared. This side factors, just like we had yesterday with completing the square. We do have a single set of parentheses with x, and what goes inside this parentheses is the sign and term before we squared it to find c, which is going to be our positive b over 2a. On the other side, we need to combine these like terms. Now, for us to be able to add like terms, well, I'll write this out. I'm not necessarily planning on writing this out, but that's fine. For us to be able to add or subtract two fractions, the denominators have to be the what? Same. One of them has 4a squared on bottom. The other just has a. So what this other side's missing is a factor of a and 4. So for us to be able to add or subtract, both denominators have to be 4a squared. Now luckily for us, the one on the right already has 4a squared. The one on the left doesn't, so we multiply top and bottom by 4a so that the denominator does become 4a squared. The numerator 4a times negative c is going to be negative 4ac. Now at this point here, we can add them, giving us 4a squared on bottom. And we could say negative 4ac plus b squared or b squared minus 4ac. We just flip the order. Does that kind of make sense? I mean, having a full grasp of what we're doing here doesn't really matter. But again, what I'm trying to show you is how we get to the next solution or the next way to solve. Okay? Next thing we have to do is take the square root of both sides. And here the square root and the square cancel. Telling me that x plus b over 2a is equal to plus or minus. I'm going to split this apart. We have b squared minus 4ac over the square root of 4a squared. Now, because of our properties of addition and subtraction, the square root of b squared minus 4ac, that is as simplified as it gets, especially in this general form. Because the only way to simplify that radical is if I can rewrite it as a set of parentheses squared, a term being squared. B squared is being squared, but because the minus 4ac, they are stuck together, I can't just split them apart. Now the denominator, 4a squared, is a single term being multiplied together. We can simplify that because the square root of 4 is 2, and the square root of a squared is a. It's just 2a being squared, so that does simplify. Last but not least, reusing colors, that's fine. I'm going to subtract negative b over 2a from both sides. And what this tells me is that x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Or, because the denominators are both 2a, we can make this as a single expression. Now, the question is, so what? Because now the big question is, so what? Why does this matter? Well, we said that we just solved this for a quadratic equation. We didn't set a value for a, b, and c. So realistically, this here is the solution for any quadratics with a, b, and c. So no matter what a, b, and c's values are, I can plug them in for a, b, and c, simplify, and we have our solution. That is the nice thing about the quadratic equation, is that if we let a, b, and c real numbers such that a cannot be 0, this right here is the key part. The equation ax squared plus bx plus c equals 0 are the solutions given that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now again, I did all of that on the previous slide to show you how we get there, how we get the equation, where the equation comes from. Because it's not just some equation they made up on the spot. We literally used a solution, a method to solving quadratic equations on the general equation itself, and we got a formula that works. So, let's look at this first one here. Unlike completing the square where we're going to have a number on the other side other than 0, we need these equations equal to 0. We need everything on the same side. So the first thing we need to do to solve this by the quadratic formula is to what? Move everything to the same side. We're going to subtract 5 from both sides, telling us that x squared plus 3x minus 5 is equal to 0. Questions on this here? All right, guys. Focus up here. So, questions on how we got to this point here? So we needed to get this equation equal to 0 so I can figure out what the value of a, b, and c is. Negative 5. So a is indeed 1. A is the number in front of x squared, so it is 1. B is the number in front of x, which is positive 3. And c is our number without a variable, which is negative 5. Questions on how we got this equal to 0 or found the values of a, b, c? Any questions on any of this so far? Now at this point, we're going to plug it in. So we have x equals negative. Our value of b is 3. Plus or minus. Square root. Our first term inside the square root is b squared, so we'll have 3 squared minus 4 times a. Well, our a value is 1 times c, and our value of c is negative 5. All over 2 times a, 2 times 1. So all we've done so far at this point is taken the values of a, b, c, and plugged it in for A, B, and C respectively in the quadratic formula. Questions on this so far? Now we need to simplify. For the most part, there are going to be parts we can type in and simplify, but on a whole, we'll simplify it step by step. A lot of it is going to be calculator work. Some of it we don't need a calculator for. Like the first part that we have here, highlighter. As this here, we have -3, which is what? -3. Plus or minus. I'm going to deal with the square root here in a minute. On the bottom, we have 2 times 1, which is 2. Okay. Yeah, both of these we really didn't need a calculator for. It can do it itself. We can do it ourselves because -3 is -3. 2 times 1 is 2. Unfortunately, there's not a symbol in the calculator for the plus or minus. You wouldn't be able to do it all at once. You could do the positive and the negative case. And for that there, it's, I would say, a little bit of roll of the dice. Because 30xs, as long as what's inside there is positive, it's going to work. It'll give us a solution, and we'd be fine. We'd do it once for plus, once for minus. But the issue is if there's a negative inside that radical, the 30xs does not like negatives, so it's going to throw up a domain error. We're going to have to fix it, which is fine. Okay, well, we can use the graphing calculator because it can use negatives inside radicals. But if that radical doesn't simplify, if we're left with the square root of 2 or square root of a number, it's going to convert everything to decimal, and then we're going to have to go from there. Because unfortunately, graphing calculator will turn it back to a fraction. It doesn't keep it in simplest radical form, so they both have issues. Does that make sense? The first thing I would do is what's inside that radical. Both calculators will simplify it, will work it nicely. Because we have 3 squared minus 4 times 1 times -5. Apparently I didn't open up the calculator app yet, so I'm going to go and do that now. Because at this point, I would type all that in the calculator, let it do it for us. Parentheses 3 squared minus 4 times 1 times -5. I would type it in exactly as it looks, exactly as we have it. It tells us it is 29. So what that means for us is that inside this radical, we have the square root of 29. So for the 30xs, that's fine. It's a positive radical. It can take the square root of 29. If I go second, square root 29, it tells us it is square root of 29. Which means if we typed it into the graphing calculator as a whole, it would have simplified it all the way to decimal form. And wouldn't get us back because we have to leave it in radical form. So we have this here. Okay? Questions on this so far? Do the top 2 numbers, and we look at a radical, the number in front of it, are both of those divisible by 2? Is -3 and the number in front of our radical 1 divisible by 2? No. We can't simplify further. That is literally it. Are you ready for the next one? Solve 3x squared plus 4x equals 10 using the quadratic formula. Well, I'm going to have to rewrite this, mainly because I don't have room to write underneath it. I don't think y'all have anything written underneath yours. Okay. Using the quadratic formula, what's the first thing we need to do? We need to get it equal to 0. So how can we do that? We can subtract 10 from both sides, telling us that 3x squared plus 4x minus 10 is equal to 0. Ax squared plus bx plus c is equal to 0. We need to find the values of a, b, and c. A is 3, b is positive 4, c is negative 10. So a is positive 3, b is positive 4, c is negative 10. We take the number and the sign. We do not take a variable with a, b, and c here. A, b, and c a will never have x squared, b will never have x. It's just the number. X is equal to negative.
May I have your attention, please? I need all seniors to report to the library at this time. All seniors need to report to the library at this time. Thank you.
So we have negative b. Well, our b value is 4. So we say negative, parentheses, 4, close parentheses. We have our plus or minus. Then we have the square root. So b squared, so we'd have 4 squared, minus 4 times our a value, which is 3, times our c value, which is negative 10. All over 2 times a, 2 times 3. Questions on how we got to this point here? All right. Negative 4 is going to be what? Well, negative 4. The denominator, 2 times 3 is 6. We didn't need that extra. Now our radical, we can simplify what's inside the radical. Our 4 squared minus 4 times 3 times negative 10. So in the calculator, we do parentheses 4, close parentheses squared, minus 4 times 3 times negative 10, which gives us square root of 136. Well, let's see if we can take the square root of 136, if it will reduce. Square root of 136 is 2 square root of 34. Questions on this here? Okay. We feel comfortable getting to this point. Yes? Do the top 2 numbers and the bottom number have anything in common, a number in common? 2. So we need to reduce. We need to simplify if we can. Now, there are ways to do this. The first way you can do this, if we did this by hand, is that looking at the greatest common factor on top between these 2 is what? 2. We're not so much looking at the negative, we're just looking at the number. And I can factor that out of negative 4, which leaves me with 2, plus or minus. If I factor the 2, Out of 2 square root of 34, we're left with square root of 34 over 6. 2 over 6 is what? Because we have this 2 over 6 here.
Wait, why did you put a 2 on that right there?
Here?
Yeah.
So we're factoring out what's in common with 4 and 2.
So that, or just whatever.
So when we factor it out, like with factoring, where we pulled out the greatest common factor, that's what we're doing. Because I'm pulling out that greatest common factor because here we can't just divide by 2. We need this multiplication. Because now we can simplify the 2 and 6. Because 2 over 6 reduces to 1/3. We have 1 on top, 3 on bottom. Which really just means the top is -2 plus or minus the square root of 34. So this is simplified form. Questions on this here? Now, as long as it doesn't have I plus, -2, -4 plus 2 square root of 32 over 6. I just picked one of them. It's a positive or negative case. It really doesn't matter which. And we get this here. So what it's telling me is that the -4 is going to become -2. The 2 square roots of, I typed the wrong number in, so that's not 32, 34. Let's try this again, because otherwise that's not going to make a whole lot of sense. So let's do -4 plus 2 square roots of 32. That's it. All right. Plus 2, 34 over, okay. There we go. Not 32, 34. But here, so now that we actually have the right number in the radical, we can see that the -4 just reduces to -2. This 2 square root of 34 reduces to the square root of 34, and the 3 reduces to 6. So that means we could take this here and use the calculator to tell us that it reduces to this here. It does switch. For some reason, it likes putting the radical first, but that doesn't make a big difference. Questions on this here? Okay. We ready to look at the next one? X squared minus 6x plus 4 equals 0. All right, guys. Focus up here. So this here, x squared minus 6x plus 4, it is already equal to 0. We don't have to do anything to get it set up. We can already go on and identify A, B, and C. A, the number in front of x squared is +1. B, the number in front of x is -6. And our C is +4. So we have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Now the first thing we can do is plug in our value of b. All right, guys. Now our value of b is -6 plus or minus the square root of -6 squared minus 4 times our a value, which is 1, times c, which is 4. all over 2 times a. Questions on how we got to this point here? Now there's a few things we can simplify first. The first is negative 6, which is just going to be 6. Our denominator, 2 times 1, gives us 2. The next thing we can simplify is what's inside that radical. All right, guys, let's focus in. 3 parentheses, negative 6, close parentheses squared, minus 4 times 1 times 4, which is 20. Now we need to see if we can take the square root of 20. All right, guys, focus up here. Now the square root of 20 is 2 squared of 5. So when we simplify the square root of 20, we do get 2 squared of 5, telling us that we have 6 plus or minus 2 squared of 5 all over 2. This time I'm going to use the calculator to show how we can use the calculator with this here. Now the numerator is 6 plus or minus 2 squared of 5 over 2. Now we can pick the positive or negative case. It will give us a similar result. We get 5 plus the square root of 5 plus 3, or 3 plus the square root of 5. If we do the minus case, we get the exact same thing, but the radical is negative instead of positive, which is really telling us that x is equal to 3 plus or minus the square root of 5. Now the other way we could do this is by hand, and that's to factor out the greatest common factor between these here that it and the denominator have, which is 2. And the 2 and 2 will simplify, telling us that we have 3 plus or minus the square root of 5. Questions on this here, or anything we've done thus far? All right, we're going to look at one last one today, and then we will finish these up tomorrow. So the last one we have on the first page is 2x squared plus 4 equals negative 7. And again, the first thing we need to do before we can start solving this is getting it equal to 0. Well, this time, we're going to have to add 7x to both sides. Because when we add 7x to both sides, we get 2x squared plus 7x plus 4 is equal to 0.
We are now ready for all sophomores to go to the library. All sophomores go to the library. Thank you.
Yeah, they completely skipped you.
You know what it's take our stuff?
Yeah.
What are you going for?
Jocelyn's.
Austin?
Yeah.
Taylor.
No.
Taylor. Jocelyn's here. Yeah.
I'm in your book. Were you sure? That was
Yeah.
take this other clock. Take this other clock back.
Yeah.
I joined there.
All right, guys. All right, guys. We're gonna finish this last problem and we're done for the day. So, 2x squared plus 7x plus 4. Our value of A in this case is positive 2. B is positive 7 and C is positive 4. Now we just need to plug the values of A, B, and C in. So we'd have negative 7 plus or minus the square root of 7 squared minus 4 times A times C all over 2A. All right. Questions on this here so far, how we plugged in A, B, C? All right. Mm-mm. Now let's do some simplifying. Our negative 7 is, well, just negative 7. The denominator 2 times 2 is 4. Because if we do 7 squared minus 4 times 2 times 4, we do get 17. And incidentally enough, the square root of 17 doesn't reduce. There was nothing in common with all three terms. This is as far as it goes.